Hi there. In this interview, we are going to explore one of the most difficult tensions in modern DevOps: security versus speed. Almost every team says they want both. In reality, you are constantly trading one against the other. I want you to treat this like a real interview. Pause the video after each question. Answer out loud as if you are speaking to a hiring panel. Then come back and compare your thinking to the sample answer. If you want more realistic DevOps interview simulations like this, subscribe so you do not miss the next one. Warm-up behavioral questions. Question 1. Tell me about a time when you had to push back on a fast release because of security concerns. A strong candidate might say, "In one team I worked with, we had a feature that marketing was pushing hard to release before a conference. Engineering had completed development, but during review, I noticed that a new service was exposing an internal admin endpoint publicly. It was not protected by authentication yet because it was considered temporary. There was pressure to ship and fix it later. Instead of just saying no, I framed the discussion around risk. I explained that if that endpoint were discovered, it could allow data modification without authentication. I proposed two options: either delay the release by 2 days to add proper authentication and logging, or release the feature behind a feature flag with the endpoint disabled in production. By giving options rather than just blocking the release, the conversation became constructive. We delayed by 2 days, secured the endpoint, and avoided a potentially serious incident. For me, speed matters, but not at the cost of introducing avoidable critical risk. Question 2. How do you handle conflict between security teams and developers? A strong candidate might respond, "I try to translate between both sides." Developers are often measured on delivery speed. Security teams are measured on risk reduction. If those incentives are not aligned, conflict is inevitable. In one organization, security required manual review for every infrastructure change. Developers saw this as a bottleneck. Instead of escalating the tension, I worked with security to categorize risks. We agreed that low-risk changes, such as scaling parameters or tagging updates, could be auto-approved through policy as code, while high-risk changes, such as opening new network ports, still required review. By automating guardrails with tools like policy checks in CI, we reduced friction and improved compliance at the same time. The key is making security part of the workflow, not an afterthought or a gate at the end. Question 3. What does DevSecOps mean to you in practice? A strong candidate might say, "To me, DevSecOps is not about adding more tools. It is about shifting security left while also building feedback loops that are fast." In practice, that means integrating static analysis, dependency scanning, container scanning, and infrastructure policy checks directly into the CI pipeline. It also means making results actionable and fast. If a security scan takes 40 minutes and produces vague reports, developers will ignore it. DevSecOps is about making the secure path the easiest path. It is about building secure defaults into templates, modules, and pipelines, so developers do not have to reinvent them each time. Core technical and scenario questions. Question 1. You are responsible for a CI pipeline that deploys multiple times per day. Security wants to add deep container image scanning that increases pipeline time from 8 minutes to 25 minutes. What would you do? A strong candidate might think out loud like this. First, I would understand what type of scanning we are talking about. Is it vulnerability scanning against known CVEs? Is it configuration scanning for base image hardening? Are we scanning every layer every time? If the scan is the same for every identical base image, we might be able to scan once and cache the results. We could also separate blocking checks from non-blocking checks. For example, we might fail the build only for critical vulnerabilities and surface medium ones as warnings. Another option is to move heavy scanning to a parallel pipeline that runs asynchronously after deployment to a staging environment. Production promotion could depend on passing that scan, but developers would not be blocked during inner loop development. The goal would be to preserve fast feedback for developers while still enforcing security before production exposure. I would not immediately reject the security request, but I would redesign the workflow to reduce friction. Question 2. Imagine your company wants to enable direct access to production databases for developers to speed up debugging. Security objects strongly. How would you approach this? A strong candidate might respond, direct production access is high risk, but the underlying problem is usually slow debugging cycles. Instead of arguing in absolutes, I would ask why developers need that access. If they need data visibility, we could create sanitized production data replicas in a staging environment. If they need query access, we could implement read-only access with strong auditing and short-lived credentials. We could also use just-in-time access through an approval workflow, where credentials expire automatically after a short window. This reduces persistent risk. I would frame the conversation around reducing mean time to resolution while minimizing blast radius. The solution is rarely full access or zero access. It is controlled, observable, temporary access. Question 3. What are some examples where prioritizing speed over security might be justified? A strong candidate might think carefully before answering. In a critical incident, restoring service may take priority over full compliance checks. For example, if a misconfigured firewall rule is blocking customer traffic, temporarily relaxing a restrictive rule to restore service could be justified, as long as we log the action and follow up immediately. In early-stage internal tools with no external exposure and no sensitive data, we might accept certain trade-offs temporarily to accelerate experimentation. But that should be an explicit risk decision, not accidental negligence. The key is that these decisions are conscious and documented. Speed can outweigh security in certain contexts, but only with awareness of impact and a plan to close the gap. Question 4. How do you design pipelines so that security does not become a bottleneck? A strong candidate might explain, I start with secure templates, for example, pre-approved base images, pre-configured CI steps for scanning, and infrastructure modules with built-in best practices. That way teams do not start from scratch. Then I focus on fast feedback. Static checks early, heavier checks later, but before production. I also use policy as code, so rules are versioned and transparent. Finally, I measure. If a security check frequently fails and blocks releases, I analyze why. Is it misconfigured? Is it catching issues too late? Security that is too slow or too noisy will be bypassed. The goal is alignment, not obstruction. Question 5. Your company wants to implement mandatory code reviews by a security engineer for every pull request. Developers argue that this will slow releases dramatically. How would you approach this? A strong candidate might think through it like this. First, I would acknowledge that reviewing every pull request manually is unlikely to scale, especially in a high-velocity environment. If the team merges dozens of changes per day, a small security team becomes the bottleneck. So I would step back and ask what problem we are trying to solve. Is there a pattern of vulnerabilities slipping into production? Are there specific high-risk areas like authentication, payment logic, or cryptography? Instead of reviewing everything, I would propose a risk-based approach. For example, we can define sensitive code paths that require mandatory security review. Changes in those directories trigger a required approval from a security engineer. Other changes can rely on automated checks plus peer review. I would also invest in automation. Static application security testing, dependency scanning, and linting for insecure patterns can catch a large class of issues automatically. Manual review then becomes focused on logic-level vulnerabilities that tools cannot detect easily. This keeps delivery speed high while ensuring that high-risk changes receive the right level of scrutiny. Question 6. Imagine leadership wants to disable certain security checks in CI because they are causing frequent build failures and delaying features. What would you do? A strong candidate might respond, I would not immediately agree or disagree. I would look at data. What percentage of builds are failing due to these checks? Are they mostly false positives? Are they catching real issues? If the checks are noisy, the problem may not be that security is too strict, but that it is poorly configured. Tuning thresholds or updating rule sets could reduce noise without removing protection. If the checks are catching real vulnerabilities, disabling them might increase short-term velocity but increase long-term risk and potential incident cost. I would present that trade-off clearly. One compromise might be to change the failure mode. For example, instead of failing on medium severity issues, we fail only on high and critical issues. Medium issues can be logged and tracked in a backlog with SLA commitments. I would also consider developer experience. If a security check fails with a vague error message, developers get frustrated. If it provides clear remediation guidance, adoption improves. Sometimes speed problems are communication problems. Question 7. How do you balance infrastructure hardening with rapid environment provisioning? A strong candidate might think aloud, infrastructure hardening often adds complexity. For example, strict network segmentation, private subnets, complex IAM policies, and encryption everywhere. These are good practices, but they can slow down provisioning if not designed well. I would approach this by creating hardened golden templates. For example, a Terraform module that already includes encrypted storage, least privilege IAM roles, logging enabled by default, and proper security groups. Developers then consume these modules instead of writing raw infrastructure from scratch. Provisioning remains fast because the secure configuration is baked in. If someone needs to deviate from the template, that should require justification and possibly review. This creates a secure baseline without forcing every team to become a security expert. The key trade-off is flexibility versus consistency. Too much flexibility leads to drift and risk. Too much rigidity slows innovation. The sweet spot is opinionated defaults with controlled escape hatches. Question 8. You are deploying a new API that needs to go live quickly. Full penetration testing will take 2 weeks. Business wants to launch in 5 days. How would you decide? A strong candidate might answer carefully, I would first assess exposure. Is the API public internet facing? Does it handle sensitive data like personal information or payments? What is the expected traffic? If it is public and processes sensitive data, skipping thorough testing is high risk. In that case, I might propose a phased rollout. For example, soft launch to a limited audience or behind a feature flag, while penetration testing runs in parallel. We could also conduct an internal security review and automated dynamic scanning as an interim measure. That does not replace a full test, but it reduces risk compared to no testing. If the API is internal and low impact, the risk profile is different. In that case, we might accept launching earlier with a commitment to complete testing before wider exposure. The decision depends on impact and likelihood. I would make the risk explicit to leadership. It is not my role to block business unilaterally, but it is my responsibility to ensure decisions are informed. Question 9. How do you prevent security controls from being bypassed by frustrated engineers? A strong candidate might reflect, if engineers are bypassing controls, that usually means the system is misaligned with how they work. Either the controls are too slow, too opaque, or too rigid. I would first look for patterns. Are teams disabling scans locally? Are they merging directly to main to avoid pipeline delays? That signals a trust gap. The solution is often collaboration. Bring developers and security together to review pain points. Maybe a scan can run in parallel instead of sequentially. Maybe policy checks can be evaluated earlier in the process. I would also promote transparency. Make security policies version controlled and visible. When people understand why a rule exists, compliance improves. Ultimately, culture matters. If security is seen as an adversary, controls will be bypassed. If security is integrated into the development lifecycle with shared goals, speed and safety reinforce each other. Pause here and think about how you approach these tensions in your own environment. In the next part, we will move into high-pressure scenarios where trade-offs are not theoretical, but urgent and ambiguous. Pressure and judgment. Questions. Question 1. It is Friday evening. A critical vulnerability is announced in a widely used library that your production systems depend on. There is no confirmed exploit yet, but social media is already buzzing. Patching will require redeploying multiple services and could introduce instability. What do? A strong candidate might think through it like this. First, I would slow the situation down mentally. Urgency does not mean panic. I would assess exposure. Which services use the vulnerable version? Are they internet-facing? Do we have compensating controls like a WAF, network segmentation, or restricted access? Next, I would look at the nature of the vulnerability. Is it remote code execution, privilege escalation, or something that requires authenticated access? The severity rating alone is not enough. Context matters. If the exploit is trivial and the services are exposed publicly, I would lean toward patching quickly, even if that means late evening coordination, but I would not rush blindly. I would stage the rollout, perhaps canary first, monitor closely, and ensure rollback is ready. If exploitation requires very specific conditions that do not apply to us, I might decide to patch within 24 to 48 hours during a controlled window rather than immediately. I would communicate clearly to stakeholders, not just what we are doing, but why. The key is balancing likelihood of exploitation against risk of introducing new outages through rushed changes. Question 2. A major customer demands a custom security feature that will significantly slow down your deployment pipeline and affect all other customers. Sales says this deal is strategically important. Engineering says it will hurt overall velocity. How do you approach this? A strong candidate might respond thoughtfully. I would start by clarifying whether this requirement truly needs to apply globally. Can the feature be isolated to that specific customer environment? If so, we reduce impact on others. If it must affect the shared platform, then we are dealing with a strategic decision. I would quantify impact. How much slower will deployments become? Will it add minutes or hours? Will it increase operational risk? Then I would facilitate a conversation between engineering, security, and business. My role is not to choose sides, but to ensure trade-offs are visible. Sometimes slowing slightly for a large strategic customer is justified. Sometimes the long-term cost outweighs short-term revenue. If we proceed, I would look for ways to minimize friction. Maybe the new control can be automated, or maybe it can run asynchronously without blocking every deployment. The mature response is to treat it as a system-level decision, not a personal conflict between teams. Question 3. During an audit, you discover that a team has been bypassing security policies to ship faster. Nothing catastrophic has happened yet. Do you escalate immediately or handle it quietly? A strong candidate might think carefully. First, I would understand why it happened. Was it deliberate negligence, or was the policy impractical? If a control is being bypassed consistently, that is feedback about the system. I would address it with the team directly before escalating, explain the risk, and listen to their constraints. Maybe the process was too slow or unclear. If the bypass introduced serious exposure, I would escalate appropriately. But I would frame it as a process failure rather than an individual failure. The goal is to restore alignment, not punish. However, if there is clear disregard for security with high-impact risk, then escalation becomes necessary. Risk tolerance has limits. Question 4. Your organization is preparing for a major launch. You know the security posture is not ideal. There are open medium severity vulnerabilities and some manual processes. Leadership wants to proceed. Do you block the launch? A strong candidate might answer with nuance. Blocking should be a last resort. I would first categorize the risks. Are these vulnerabilities exploitable in the current configuration? Are they theoretical or actively exploited in the wild? If the open issues are medium severity and mitigated by other controls, I might document the risks, ensure leadership signs off on risk acceptance, and proceed with a plan to remediate quickly after launch. If there is a clear path to data breach or service compromise, then I would strongly recommend delaying. And I would articulate the potential impact in business terms, not just technical terms. Ultimately, leaders can choose to accept risk. My responsibility is to ensure that acceptance is informed and documented, not accidental. That concludes this interview simulation on security versus speed. If you are preparing for DevOps, SRE, or cloud engineering interviews, notice the pattern across these questions. Rarely is the answer about choosing security or choosing speed. It is about understanding context, making trade-offs explicit, and communicating risk clearly. The strongest candidates do not give rigid answers. They ask clarifying questions. They evaluate impact and likelihood. They think about systems, not just individual tasks. Now I want you to reflect. Which question felt the most uncomfortable? Was it the 0 day on a Friday evening, the audit discovery, the pressure from sales, or the decision to launch with known vulnerabilities? Pause and replay the hardest one. Try answering it out loud. Think about how you would justify your decision to both engineers and executives. Real-world DevOps is not just about tools. It is about judgment under uncertainty. If you found this useful, subscribe so you do not miss the next interview simulation. In the next session, we will tackle another high-pressure scenario that tests not just your technical knowledge, but how you think when the stakes are real. Take a moment to reflect on your own environment. Where are you currently optimizing for speed? Where are you optimizing for safety? And what would you change if you had to defend that balance in an interview tomorrow? I will see you in the next one.